You are welcome to today's class. In this class, we'll be looking at this problem in differential equation. We'll be looking at this problem in differential equation. But first of all, pause the video, give it a try. Solve it. And if you can't solve it, this video is for you. Okay? Now we asked to find a particular solution of this problem, of this equation, given a condition that our y is equal to 3 when x is equal to 0. Okay? So I will need to erase, but just take note that your y is equal to 3 and your x is equal to what? 0. So write it here, y equals to 3, x equals to 0. X equals to 0. So I will need to erase this. All right. Now, while solving this, we need to divide both sides by this exponential. Divide both sides by the exponential. Okay? This cancel this. Now I'm left with the y over the x equals to 4 over the exponential x. Okay? Now, what's the next thing to do here is that we need to integrate. We need to integrate. Now, but before we integrate, I would like to simplify this further. So this is what I'm going to do. We have the y dx equals to, this is the same thing as 4 times 1 over exponential x. Do we believe that? Because 4 times 1 will still give me 4, which is the same thing as this over this. Okay? So, and this is also equals to what? It's also equals to 4 exponential raised to power minus. So this, everything here is also the same thing as this, because so it's also the same thing as this. Okay, take note of that. All right, so I will need to integrate this. Yes, I will need to integrate this. So for me to integrate this, I will need to, let me erase this part. Okay, let me manage this space, this small space. Let's try to manage it. So given that the y dx is equals to this, so that is the y over the x equals to 4 exponential minus x. Okay, now if I'm integrating this, let me tell you something. You know, in differentiation, if you have y given to be an equation, so any equation, it could be 2x plus any number. You know, when you differentiate this y, if you give you what? It will give you, if you differentiate this y with respect to x, it will give you the y dx, right? So you know that I differentiate y to get this. What if I want to go back to this? You know, from here to this, and I want to come back to this to get y. I will have to do what? Integrate. You know, integration is the opposite of what? Differentiation. So if I differentiate y with respect to x and I get this, so for me to get this y back again, so I will need to integrate this, the y dx. So if I integrate the y dx here, that is, I will integrate both sides. So if I integrate this y dx, this dy dx, if I integrate it, it will give me y. Take note of that. Okay, equals to, so if I'm to integrate this, now I will bring out this constant, this number out. I will have 4 integral exponential. I've not integrated it here too. I just have to bring out the constant. So if I'm to integrate it now, I will have 4 times, or let me just say, or 4 dots, or 4 times. Okay, now there's a short way I used to get that. There's a short way I usually use to get all this exponential. I don't need to waste time. For example, if I have exponential 2x, for me to integrate this, I will just say what is here divided by the differentiation of the power here. So you know, if I differentiate it, it will give me 2. So it will just be exponential 2x over 2. That's just it. So if I'm to integrate this now, I will just say exponential minus x over, what is the derivative of the power here? So you know, the power is minus x. So what is the derivative of this? The same thing as what? Minus 1. Okay, so I will have here to be minus 1. Okay, so I will have y equals to 4, or I can just use the minus to multiply it. It will be minus 4 exponential minus x over 1. You know, it's the same thing as over 1, so I can leave it like this. Now I've gotten my y to be this, but mind you that whenever you are integrating, always put your constant. Don't forget, put your constant here, put your constant. See, now from here we're told that what, we're told that our y is equals to 3 while our x is equals to what, 0. So I will need to substitute my y, the value of y, and the value of x to get the value of this constant. You understand? So my y is equals to 3 equals to, now my, here I have minus 4 exponential raised to power of what, minus 0, because our x is equals to 0 plus c. Now we have 3 equals to minus 4, this exponential minus raised to power minus 0, you know, anything raised to power minus 0 or raised to power 0 will give you 1. So this everything here will give me 1. So when it give me 1, if I multiply it with this minus 4, it will still give me minus 4. So I will be left with what, plus c here, that is the constant. So if I bring this 4 to the other side, it becomes 7 equals to what, c. That is our c, which is constant, is equals to what, 7. Now we're almost done. Okay, so let's finish the remaining work here. Let's try to finish it here. Now that I've gotten the value of my constant, so I will come back to the value, I will come back to the equation of y here. The equation of y here, I will say what, y equals to, you know, y is equals to 4, y is equals to minus 4, sorry, is equals to minus 4 exponential minus x plus c. Okay, now if I substitute, if I replace c now with 7, this, whenever, if I replace this c now with this 7, so we have what, y equals to minus 4 exponential raised to power x plus 7. So this is our equation. Although you can decide to rearrange this, and you can decide to leave it like that. So if you want to rearrange it, you can say, okay, y equals to minus 4 over, you know, this one, this exponential raised to power minus x is the same thing as 1 over exponential x. So you can say, you can have something like this, exponential x plus 7. So these are final answer. Don't forget to like the video, don't forget to subscribe, comment and share. Thank you.